So this lesson we're going to start by looking at the slides that are normally posted for you. I just want to bring a few things to your attention. Aside from the standard operators and math stuff that we've already talked about, there's a bit of a review before this, but here's some of the shortcut operators that you're going to see a lot in Java. So if they're down listed here. There's more than this, but these are generally the ones you'll find that may be useful to you in your program. Instead of having to write x equals x plus y, the shortcut would be x plus equals y. Incrementing things, plus plus, that's x plus plus, x equals x plus 1. So something that you'll probably find useful, you're going to see them as we get into other techniques in Java like looping. But for now, just some new math stuff. We don't really want to focus on the basic operators today, since we're learning a little more about how objects work and getting them to do things for us. That's what our focus is going to be for today. So we're going to take a look at the math class. Now, I have a new project set up so we can practice some of the math things. And the first thing you need to know about the math class is it's a very special way of accessing the things in math class. It's called a static class. So what it means is static is a keyword that means there's only one instance for the entire class. So to give you an example, if we were to say, you do your graphics program and you have 10 J circles. Each of those circles has its own color, its own thickness, it has all these properties attached to it, and it starts to pollute up the memory. And that's okay if that's your intention, but we want to conserve memory where it makes sense. And one way to do that is using static, which is a keyword in Java. If you type static in, you'll see it highlights as blue, meaning this is a reserved keyword. So what static means is, instead of every object getting its own copy, there's only one copy that the whole class refers to. Now, why would it make sense to do that? Well, for example, let me show you system.out.println. I'll show you one of them. The math class, well, it defines the constant pi. So if we run this program, there's pi. So what I mean is, it makes sense to do the static, because why would you copy pi for every math object when there's only ever one instance of what pi means to us? That way we can have 1,000 math objects and still only need to use one piece of memory to store pi. The way you can tell when something is accessed through a static method or field in this case is that it's the name of the class directly where you apply the dot operator. Like normally you would do something like string s equals new string, right? And you do your, then you go s dot. So, whatever you were, here I use the variable and I access it through the variable. Because this variable has all of its own memory, it's storing hello and a whole bunch of methods and access to other things. However, when it's not something connected directly to that object, I'm using the whole class name here. So math.pi. There's also static methods for the string. If you hit dot, you'll see what they are. And you can see in the documentation that it's static. It's listed as static. So, for example, if you have a double that you want to convert to a string, then that's one way you can do it, is you can go string dot value of double and get your a string back from it. Anyways, so static access is just an efficiency thing, and that's how you access things in the math class. Other constants, I mean, you probably won't use Euler's constant too much in our class, but it's another very popular one that you'll run into. There's more, but it's not just constants that you have access to in the math class, it's also methods. So when you hit the dot, you're going to have a whole list of things. Basically anything your calculator has on it, this also has access to it. So for example, you might say, oh, well, why don't we take a look at something familiar like a square root? Well, it's kind of hard to see there, but it's the squirt, square root. And if I said, what's the square root of 4? Then Java will go through, calculate it for me, tell me it's 2. Okay, so math has a whole pile of functions, and I'm going to go through a list of ones that you're responsible for. But you access them all directly through the math class. So math dot, here's the absolute value. What's the absolute value of negative 10? It's positive 10. Now the reason it makes sense to do this for methods as well is normally when you create an object, that object gets a copy of every one of those functions in the class as well. So like the set color, set thickness, all those things you have in the graphics classes, each one of the objects gets its own copy, and it can get very expensive if you don't mean to do that. So why would you have 10 copies of the absolute value function when it's identical for every for every time we want to use it, right? There's no need to differentiate different absolute values. There's only one. That's why it's done static. So don't worry too much about those messy details, but if you're going to take the second programming course or go on when you finish high school, this is definitely a technique you're going to need to know more details about. Okay, so let's go through what you're responsible for. So we talked about square root. I just showed you the absolute value. There's other ones in it. The POW method is another one, which is quite common. So let's go down to POW. So POW is, for example, let's say I did POW 3, 2. This is the base, and this is the exponent. So this is 3 squared, which would give me 9. You don't have to use integers. So for example, like I could do 3.5 to the 2.1, just like your calculator could, and it'll give me the decimal equivalent for what it's supposed to be. Aside from the power function, or exponent, I guess might be another way for you to think of it, all the trig methods are in there. So for example, sine, cosine, and tangent. So sine is here, tangent's here, cosine is also in there. We've already gone past it. If you want to round a number, so for example, let's round 2.5, comes up to 3, but 2.4 would round to 2. So basically, if you're looking to manipulate doubles or integers, the math class is a good place to turn. But let me show you some things you might not be familiar with, and you know, as you go through, right? If you don't know what the cubert is, it's the cube root. So you should still be relying on the documentation in order to help you learn to use some of these classes. The arc sine, that's the inverse, right? This is the one that's like sine -1 on your calculator. It gives you an angle. One tricky thing that's not going to be, you know, it's going to be sort of surprising to you is until you get to grade 12 and you start working on the number system that we call radians, you're not going to be getting results you think. Like for example, if I wanted to know what's the sine of 30 degrees, I should get a half out of that, but I don't. I get this weird number. To convert from degrees into radians, you have to multiply by pi over 180, and that will convert it into radians. So it wasn't quite perfectly a half because of course, the way this is working, it's not a symbolic math calculator. It's using some numerical methods. So, you know, if you're worried about that kind of thing, some of you have asked me like, oh, well, you know, what should I do? You can do some tricky rounding and other things, but I'm not, anyways, it's not going to be marked as part of the accuracy. If Java's accuracy is not your responsibility is what I'm trying to say. So when you do trig, that's one thing you're going to have to remember is if you want to do some trig, you're going to have to multiply by math.pi over 180 in order to go into the degrees that you're used to working with. Okay. And of course, you know, if you're getting weird answers, you should always feel like you can ask me when we're working in the lab on this stuff. So let's keep going at a few of the common math functions, and then I'll go into a tricky one coming up later. So floor is one that you might not know about, but if I had something like 3.9, now you might be inclined to say, well, let's round that up to 4. But what if you don't want to round it to 4? What if you actually want to throw that decimal away? You could cast it to an integer, but in mathematics we call that the floor. So 3.9, if you throw everything away, the floor is 3.0. Basically, like if you think about the number lives in, I mean, this is going to be a really bad, I don't know if this is an analogy that's gonna really sound that professional, but if you think about a number living in a room, and let's just say that the number is let's say this is where the number 5 lives, and this would be like, you know, 5.2, and this would be like 5.6, and this would be like 5.9. 6 would be there, and 5 would be there. So if you think about it like a room, then the floor is when it drops down to the bottom. So I'll use the number 5 here to show you what I mean. It's going to take that number 5.9 that lives in this room and put it down to the floor, which is 5. What if I wanted to go higher? That's called the ceiling. So if that's the floor, that's the ceiling, and 5.9 ceiling is going to be 6. Now it's different from rounding because this is the room that 5 lives in. If I want to bring it up 1, that's the ceiling of 5.1, and it jumps all the way to 6. So the only thing you have to be careful about when you think about floors and ceilings is you have to think about where it lives in the room. So for example, if I do a negative number, this is where people get confused. What happens if I go, what's the ceiling of negative 3.2? Well, if you actually make a room out of it, this is negative 3. This would be negative 4 down here, right? So it's actually not the way you would expect it unless you go, oh yeah, negative 3.2 is in here, just below. Maybe this is like negative 3.5. This would be like negative 3.9, because these are getting more negative as I go down. So if I want to know what's the ceiling of 3.2, it's actually going to go up to negative 3, because that's the number up here. So even though it's chucking that 0.2, it's going to the next biggest integer, which is negative 3. So that's another way that ceiling is referred to. We call that the next largest integer function. So it goes to the next integer larger than that. And again, with negatives, if I want to floor it, if you think, oh, all it does is chuck the decimal and it's going to go to 3.0, that's not where the room where it lives. Negative 3.2 lives in this room. The floor is down here at negative 4. So negative 4 is there. So again, this is different methods of rounding, like round, ceiling, and floor. Usually when you're doing some kind of calculation and you need to figure out, like round up, round down, however it is, that's where ceiling and floor come in. Okay. Logs, if you do use logs, that might be something you would use. If you have two numbers and you want to know what's the largest of the two, you could do something like maximum, what's the largest between 5 and 10. That might seem silly in this example because you obviously know what the larger number is between 5 and 10, but I'll show you how you could use, why it would make sense to do this. I could use some input here, so let's get a keyboard. And I'll go int 1 is keyboard dot next int, and int 2 equals keyboard dot next int. Right, you don't always know the values before runtime. Whoops, should be keyboard. And I'll just prompt just for good practice here. So say enter two numbers, and the largest is maximum of 1 and 2. So enter two numbers, -7 and 32. So the largest is 32. So that's one way. Of course, it works similarly if we were looking for the minimum. We'll have other ways of finding minimums and maximums as you learn more Java techniques, but for now, you can use the math class to do that. Let's see here. I think that covers the ones that we're going to look at. Oh, there's a method there that's handy. Look at that. So if you do want to convert to degrees, you give me an angle in radians, and it'll convert to degrees. So for example, in the radian system, pi over 2 is actually 90. So why don't we just, we could convert that instead of doing the multiplication. I'm sure that's all it does. 90. There's also one there that said 2 radians. So that could be handy for you if you're trying to figure out that you got to use radians, and let's see if that gives me a more accurate answer. So the sine of, the sine of 30 degrees in radians, because that's how Java trig functions, that's the same number. So it would have done the same thing as I did. So either is acceptable, but both might be handy for you to use. All right, so the last one that we wanted to talk about was random numbers. And this is pretty easy when you get the hang of it, but it's something new and it's worth talking about a little bit here. So let's take a look at what random numbers look like in Java. So there's the random method. Now there is a random class. So if you're doing a project of some sort, I'm certainly not going to tell you that it's incorrect to use the random class. It's got a lot more versatility and a lot more methods. And here's the documentation, so you know you can find different ways of doing it. It's a little more user-friendly in some instances. So anyway, I'll just put that out there as something you can use. However, I'm going to emphasize that you should try using math.random, because those of you going on to do advanced placement computer science, this is the method for advanced placement. That way you won't have to relearn it if you're going to take advanced placement computer science. So when I run this, it's going to spit out a number with a seemingly random value. So 0.344, something crazy random. Let's run it again, 0.11. And notice I'm not changing my program, but it keeps spitting out different numbers. Now, I'm saying seemingly random because it's not actually random. It is predictable, but anyways, what you can count on is when they do create these random number generators, they make them uniformly distributed. So you have an equal probability of getting any number in this range. And I don't know if you've picked up on what the range is, but this range here is from 0 to 0.99999 forever. So any number in that range is what this will spit back at you, and they all have an equal probability of happening. There's no one is not favored more than the other. So what happens if you don't want to use that range? Well, if I multiply by 10, then what's going to happen is I used to go from 0 to 0.99999, but when you multiply by 10, well, 0 times 10 doesn't do anything, but 0.999 will become 9.999. So multiplying by 10, you're going to see the new random numbers I get are from 0 to, basically we're going to call it 10, a little less than 10. So these are random numbers from 0 to 10. Okay? Well, what if you don't want to start at 0? What if you want to start somewhere else? Let's say we want to start at 5. Okay, so if I add 5, that means this one is going to go 5 higher, but so will this. Oops. So this is going to be numbers from 5 to less than 15. So I won't get anything less than 5 or over 15 here. So this is how I'm just giving you an idea. We can shift this range to work any way we want. And of course, you might say, yeah, but I don't want all these decimals. My simulation or whatever I'm doing doesn't need decimals. I'd actually prefer to have integers. Well, then we just cast it the same way that we did looking at other things here. So 7 now, 10, 5. That's why we went through casting with you earlier in our lessons. Now you can cast from the integer to a double to an integer when you want it. However, I will remind you that you have to be careful because casting has highest precedence of the operators here. So what will happen if I do this? That means the first thing to happen, it's not going to multiply by 10. It's going to take this and cast it to an integer. And remember, it's a number from 0 to 0.99999. So what will it do when I cast it to an integer? It's going to chop off any decimal. So now it's not so interesting because this will always be the value 0 times 10 is 0. Every value coming out of this is going to be 5. So that's probably the only mistake I see people getting frustrated over is why isn't my number generator working? It's probably because your casting hasn't been done properly. Okay, so how can we predict then what we want for a range? So let's say, for example, we're going to work through, we want the range from 10 to 25. Okay? What this means is we actually, if we count them up, we want, if you count them on your hands, that's 25 minus 10 plus 1, which is 16 values. I guess you need some toes to count that too. But that's how many values I want. So that's what I can manipulate here, is if I want 16 values, this would be the numbers from 0 to 15.9999, but chopped off is 0 to 15. So that's 16 random values. 0 to 15, if you count them, there's 16 values. And I would need it to start at 10. So what I'm going to do then is start it at 10 by adding 10 to the random number I'm generating. What that'll do is make this go 10 to 25.999 or 10 to 25. So that's my range in here, is any number from between 10 and 25 will show up now in this random number generator. Okay, so I'm going to change it for a second, and let's just say that the range that you wanted to, maybe I'll leave that there in case you want to see a bit of a template. What if I want the range of values to go from 50 to 79? Okay, so try this one, pause the video, see if you can make them work. Otherwise, I'm about to show you how to scale this with the random number generator to go from 50 to 79. Okay, so how many values do we want? We want 79 minus 50 plus 1. That's going to be 30 values. So we want 30 values, and we want them to start at 50. So I need 30 values, and I want it to start at 50. So this is going to give me the range now. I'm casting them to integers. It's going to be, what did we say? 50 to 79. So if I run it, those are the values I'm getting. Alright, so now I'm going to give you a bit of a formula. It is handy to know. You can refer to it here. It's also in the slides. What if we wanted the range from A to B? Meaning you give me any two numbers, A and B. Okay. What I want then is B minus A plus 1 values. And I want it to start at A. So the formula then, I can go int A equals 10, int B equals 25, would look like this. B minus A plus 1, and start it at A. So now I can control this random number generator by just changing my range here, my minimum and my maximum. So this will be values that go from 10 to 25. So what if I want to change it? Let's go 100 to 250. Okay. It's always been scaled just by changing A and B. So this is the formula that you can work with when you're dealing with integers. Again, it's also in the slides available to you if you need to find it afterwards and you don't want to scroll through the video. What if you're working with doubles? Okay. It's very similar, except you're going to have the 0.9999 on the end of it because you won't be chopping off this much of it here. So for example, now instead of being from 100 to 250, it's going to be, the decimal is going to still be there. So it'll be 100 to 250.99999. So it could go over 250 now, but it can only do it by whatever the decimal number is in here. So basically what you're saying then for doubles is you have to figure out what the number is that you don't, what's the maximum you can expect. It's going to change it slightly. So for doubles, again, that's a decimal value. If you want from A to B, but not including B itself. Okay, let's take a look at an example. From 10 to 35, but not including 35. That means you want from 10 to 34.99999. Because we're not chopping it off, that there, which is equal to 1, it's actually going to mean we want the values from 35 minus 10, which is 25 values. And we want to start at 10. So in this case, if I was using doubles, you don't need that plus 1 there because you're keeping the decimal answers. The formula just changes that one thing is knocked off. So if I said I wanted to go from, what is our example here, 10 to 35, This will be 25 values. So again, if you want to hand trace it, if I have 25, that would be 0 to 24.99999. Then add 10, it becomes 10 to 34.99999 because I added 10 to here and I added 10 to there. So that's the range that I was looking for, 10 to everything but 35. So the only change in the formula is there's no plus 1. So here are the new values that I'm getting that have decimals in them, and it's everything less than 35 but greater than or equal to 10. So that is also provided in your slides if you don't want to refer back to it. But random numbers are huge as far as simulations go and playing games. When you want the computer to behave in a way and you want it to make a decision about something, you know, we're going to be using random numbers in your video games and things so that you know, this will decide whether or not the bad guy is going to you know, shoot a gun or jump or move out of the way or attack or not attack. Anyway, things like that we use random numbers for. Or, you know, if it's a board game, where do you put the pieces when you start? Well, you need to generate some random starting behavior. So that should be enough for the math class for you and enough to get your assignment going.